Our next concept we're going to look at is a thing called enthalpy of formation. And we're going to use this concept in a couple of other things, using enthalpy of formation to work out the enthalpy of a reaction and a thing called Hess's law. But before we can use enthalpy of formation, we need to know what it is. So this is called enthalpy of formation, standard enthalpy of formation, or heat of formation. Those are the main terms used for this. So you've got a delta, F for formation, H for enthalpy, and the 0 is a degrees sign that means standard conditions. So it is the formation of 1 mole of a substance, so this 1 mole is important, the formation of 1 mole from its elements at 25 degrees Celsius and 1 atmosphere of pressure. Those are our standard conditions. So if I was looking at the formation of water, then the first thing I would do is I would show the elements that it's made up of, which is hydrogen and oxygen. Both of those under standard conditions are H2 and O2 respectively, and they are gases. Our state of matter does matter. The definition says it has to be 1 mole. So when I balance this equation, I see that I've got 2 moles of water. So what I have to do is divide the entire equation by 2. And that's what I've done here. So when I divide it by 2, you'll notice I've got a half mole of oxygen in this. I'm allowed to do that because these are really just mole ratios in front of the numbers. So I've now got my 1 mole of water being created. So this is the correct equation. So this would give us our enthalpy of formation of water. And if I look that number up, or am given it in a question, it's around about negative 286 kilojoules per mole. So 3 significant figures it is under those conditions. And we can use that in other calculations. So let's say we had a question that asked us to write an equation for the enthalpy of formation, standard enthalpy of formation of, and we're going to go for CO2 gas here, carbon dioxide. So carbon dioxide is what we're going to end up with. In this one, the 2 elements are carbon and oxygen. Carbon at room temperature is going to be just carbon solid. That could be graphite, it could be diamond, it's probably going to be graphite. And when we burn that in oxygen, then this is all balanced. It can be that straightforward. If it was carbon monoxide being made, by contrast, then, I'll just change colours here so they are a bit different. If it was the enthalpy of formation of carbon monoxide, which is a gas as well at this temperature, then of course I'm going to end up with carbon monoxide gas. I'm going to start with my carbon, which will be a solid, and I'm going to have my oxygen gas. Now, to balance this, I'd need 2 of these to balance out the oxygens, but I'm only allowed 1 of them. So instead of doubling this and this, instead I halve the amount of that. So I've only got 1 mole of oxygen atoms because it's half a mole of O2 molecules. And on this side I've got 1 mole of carbon atoms, 1 mole of oxygen atoms, so it is completely balanced. As I say, we're going to use enthalpy of formations in some other calculations to find enthalpies of other reactions and in a thing called Hess's law.